This group of words for grades 3 through 5, operations and algebraic thinking, and number base 10. So on the one hand, it's hard to think of movements or gestures or motions that match these words. On the other hand, I think kids need more exposure to ways of representing these abstract ideas. So we're going to try to put some of the critical terms here, there are about 26 of them, to a gesture or a motion. The first one is multiple. So what I usually do for multiple is I use my fingers like this. Multiple is often confusing for kids, the difference between multiples and factors and common multiples. But for multiples, I usually flash my fingers out like this and I say multiple. So I break the word into 3 syllables, 3 flashes, multiples. Later on, we could count by, say, multiples of 4, 4, 8, 12, 16, or the multiples of 5, 5, 10, 15, 20. We might be able to do 5, 10, 15, 20, and find the common multiple, 4, 8, 12, 16, 20, and we would touch them together. Multiples of 5, multiples of 4, multiples. Multiplication could come with a crashing, multiply, and we might even crash over and make an X. Multiply, multiply. Factors then become a way of linking things together because factors come in pairs. So let's, for example, we're trying to find the factors of 24. So that would be 24 and 1, 12 and 2, 3 and 8, 4 and 6. Factors come in pairs. So whenever there's one, there's another one. So these would be the symbol for factors. If you want to do prime number, you have just like this, 2 factors. So 13 is a prime number, 1 and 13, one set of 2 factor pairs. So it only has exactly 2 factors. Later on, we'll have a factor tree like this and the prime factorization. But this would be multiples, and these are your factors. Another idea that comes up a lot is the whole idea of division. So you can divide into 2 parts, or you can use your little division symbol over here, which we covered in the other one, divisor, dividend, quotient. If it has a remainder of 0, we'd say it's divisible. You can divide in exactly 2 parts or 3 parts with no remainder. This would be divisible with the 0, no remainder. Another important word in math at this level is the idea of the commutative, associative, and distributive properties. So to set these up, I have the parentheses. Later on, we'll have the parentheses in here for ordered pairs. So out here, I usually make my parentheses out a little wider. Parentheses. Then we have 2 things in it that need to be added or multiplied. Be commutative. You can switch the order, it doesn't matter. For 3 things, I have to use my elbow and show that it could be the elbow, the hand, or the other hand. 3 items, the order doesn't matter what you do first or second. So commutative and then associative. The big one, though, is the distributive property. So you have your parentheses, say you're multiplying by 3, multiply times this, multiply times that. Multiply times this, multiply times that. And we want to be able to decompose a number and then use the distributive property to multiply each part. So 34 times 6, you have your 6 out here, 6 times 30, 6 times 4, the distributive property. Later on, we might factor something out of the parentheses. So you might be able to take the opposite of the distributive property. When we get to the number line, we could use that again as we used before. So I'll move over a little bit here to show rounding. So we have 0, 1, 2, 3, 4, 5. If we want to round to the nearest whole number, say we have 3/4, round it to the nearest whole number. 0.9, round it to the nearest whole number. 1.5, it's right in the middle, round it up to 2. So you can use the number line to cover the concept of rounding or estimating. And I usually use this symbol, estimating, or approximate. Estimation, approximation. Another idea in this whole unit would be the idea of a pattern. So usually I just tap my shoulder and then my head. Pattern. That's a symbol that we used in grade 2 and grade 1, so you could carry it over in the upper grades. Is there a pattern here? Do you see any patterns? One of the big things we developed in the younger grades was the ideas of digits. And you can go back and watch that video, but the fingers became the digits. So each finger represented a different digit. So this would be the hundreds place, the tens place. Move over here a little. The hundreds place, the tens place, and the ones place. Then we said in the younger grades we could put these unifix cubes on there, and we could create 122. 100, 2 tens, 2 ones. And that idea of expanded. So with the 4th and 5th grade, we want to start bringing in the decimals here. So we'd have 122 and 2/10 1/100th. We always name it by the hundredths place. This would be 12 hundredths. And again, that situation, if we got this hand and we have this hand, we could even go to the thousandths. We could say 122 and 2/10, 200ths, 1,000th, or 221 thousandths. So the fingers here can represent the digits and the place values quite nicely. And depending on when you get comfortable using them, kids start to understand that you can expand the number by breaking it apart into each place value and adding it together. The final group of words that we need for this is the idea of a variable. And again, I usually use multiply here, so this becomes a variable. Later on, we're going to have the coefficient right in front of the variable. But it does say in grade 4 to represent an unknown quantity with a letter. So you could use n or x. These would be variables. Patterns are also looking for when you have an in-out table, a two-column table. So this is, for me, is perpendicular. This is going to become coordinate grid. So right up here, this is two-column table or in-out box. In-out box. We might look for a pattern with our in-out box. And those are pretty much the 26 words in that strand.